Hi friends, you are welcome to this presentation. This is reason. In the previous lesson on Staad Pro, we are able to design the column member and as well the beam member of the structure. And so in this lesson, we will be considering the design of the foundation and as well as the design of the slab. And we are going to be using RCDC to carry out the design successfully. This structure has been analyzed successfully, and then we are going to take note of the project name. This is G+3 building design. Okay, so right away I'm going to close this the start so as to be able to launch RCDC. So click on close right away, then I will launch RCDC. I click on the new tab so as to create a new project. So the project name is G plus 3 building, and then the client's name is right, and then the engineer is reason. Alright, the code of practice we'll be considering is PS8110, and then we will need to navigate to the file. So the file name is G+3 building. This one, click on it and click on open. You give the program some seconds to load. It is loaded successfully, and so at first we'll be considering the footing design, this one. So we select footing and then click on create new project. Alright, the new project is created successfully. At first you need to save this project. Click on the save. It will now take you to these provisions where you can save this project as footing, just like this, and then click on to save. Alright, so after that is saved successfully, you go to setting, click on the setting. In the drop down menu, you'll be looking at general setting. So in the general setting dialog, what we are going to be considering right here is the concrete design parameter, such as the concrete grade. We will be considering grade 20, and then for the steel grade we will be considering grade 410. For the cover, the foundation cover, concrete cover is 440 millimeter. Sorry, the type of soil is medium, so you can select it depending on the type of soil based on the soil report. So after which, all of this we are going to leave them at default. So but we will check for overturning, we will also check for sliding, and we will also consider this overburden pressure. All right, after which you click on the okay. Go back to setting again. This time around reinforcement setting. All right, the main reinforcement, the minimum bottom bar, we want to be considered 12. Okay, for the top bar you also consider 12, and then the maximum steel bars will be considered 16. All right, for the shear steel, the minimum is going to be 8. All right, and then the maximum is going to be 10. Okay, for the side face reinforcement is going to be 10, and this provision is going to be 12. And so you need to ensure that all that you have selected in the above provisions are checked in this place. Okay, we have 12, 16, and 8, including 10. So you can see all of that has been checked successfully. Okay, after which what you just need to do, you can see the rebar spacing. These are okay. The program will select based on the design. Click on OK. Go back to setting again, detailing and drawing setting. So in this provision, what we need to do is to go to the rebar mark manager. I prefer using my prefix Y instead of T. All right, upper letter Y, and then for the shear the same thing, upper letter Y. All right, okay, and okay again. So after having that done, go back to the setting again. The basic load, case we are going to be considering, is the dead load. We also consider the life load and as well as the roof load. That one, click here, take it to that provisions, just like that. Then click on OK. Click on add from analysis and OK. OK again. So in these provisions, we are supposed to come to this tab and then provide the sizes. Okay, so you go add from analysis, and then you check sliding, you check overturning, okay, and also check SBC. Okay, You can also check for buoyancy, but let's leave that provisions. Okay, click on okay. So after that is done, we are set to analyze this footing. You go straight away to the analysis tab, click right there, and then auto design. Click right there, design tab rather. So you give the program some seconds to carry out the design of the foundation footing. Alright, so the footing is being designed successfully. As you can see, the sizes are different depending on where the load is much. Alright, the maximum sizes is 2.3 by 2.3 right away on this list. So you can proceed to generating drawings based on these informations that you have straight away. Can generate your design summary, can generate your member forces, as well as the bill of quantities, the detailed drawings as well. But by then you can save this project, you can save this footing provisions. Click on the save, and you can save it in the DSF file, whereby you can use AutoCAD to open it successfully. Let us look at two of these footings that has been designed successfully. So click on this detailed drawing, right, and then check footing FC1 and FC2. Then we need the plant, we need the sections in that provisions, and then click on OK to generate the drawing right away. Alright, so these are the footing drawings. Okay, one thing in Staad, I noticed that Staad carried out over design. Alright, so you can see it has provided us both top and bottom bars for the footing successfully. You can see the footing thickness is 150. It chooses 150 for the thickness. Alright, so this is the footing design. Alright, and the section. You can export this to AutoCAD as well if you use these provisions. So if you need any other information like the calculation sheet, you can get it right away in that tab. Click on that tab, design calculation. Let's just check design calculation for FC5. Click that one and click on OK. So this is design calculation for FC1. Okay, and this is printable as well. You can use this printer and print it in PDF. Okay, or you can also save it right there. Alright, so right away we want to be designing the slab. We are done with the footing, so we click on the new to create a new project. Say yes to save this particular project. So in this we are going to be providing the project name. Okay, G3 building. Alright, and the client is Rat, engineer is Reason. Okay, the same code we are going to be using BS810, and we import the building informations just like this. This time around is slab, so you select that, and we are going to be designing the first floor slab at level 3 meter. So choose the 3 meter options and click on the create new project option. Alright, so you can see the slab has been prompted, and so what we will be considering is the imposed load, live load, and as well as the slab thickness. And there's also a provisions for the top of slab. If the top of slab you want it to be above the beam level. Okay, so I will provide this information right away. Briefly, I want to be explaining this. The imposed load has to do with the thickness of the slab, which is the 150 multiplied by the density of concrete, which is 24 kilonewton cubic meter. All right, so if you use 0.15 of the slab thickness to multiply by the 24 of the density of concrete, you will have this 3.6, as that is your imposed load. Okay, and then the live load is for the purpose of the structure. This structure is a residential structure, and so the live load is 1.5. All right, so that is how it works. Straight away we move to the setting tab, and then we'll be able to set the design parameters right away. So in this provision, where we go straight away, look at the preferred diameter of bars. Okay, we prefer Y12 and then we will choose vi8 and some other bars. In case of eventuality, the program will select from these provisions for a successful design. And so for the material properties, the concrete grades, we are going to be considering 20, and this is 410. The concrete cover, we are going to be using 25, and the thickness is, the minimum thickness is 150. Okay, so having set all of this, for the spacing, let's take the maximum spacing to be 200. The minimum spacing is 100 millimeter. Alright, so after having this set, click on the OK button right away. Alright, so for the crack width, you can click this tab so as to check the crack width. Okay, and then the initial timer cracking, you also check that. Click on the OK button and then go to the design tab, click right away and select auto design. So also it can't design because of this provision is empty. All right, so what we need to do, what I intended doing in this provision, if I select this now, I will make it fault true. Okay, it's fault already, I'll make it true just like that. If I make that true, you can see there is no more slab in this provision, meaning I'm going to consider these provisions for my stairway. Okay, my stairway, this staircase provision. Okay, so I'll go back to the design again and click on auto design. Alright, so the factors affecting continued has been changed for some slabs. Okay, do you want to evaluate the continuations? Click on yes. So the design is in progress now. Alright, so all the slabs has been designed successfully. Okay, so what you just need to do is you come straight away to this tab if you need the summary of the design, if you also need the calculations sheet. But let's look at the drawing. Okay, so you click on these provisions to generate the drawing. Alright, so this is the slab design drawing. As you can see, it is a two-way slab. Okay, all of the slabs are two ways. Okay, so you can see the T12. Okay, at 200 spacings. Okay, in all of these panels. Alright, so you can as well save this and export it to. You can save this project. Click on this provisions to save this. Okay, as slabs. Save that as slab design. So after which you can click on save right away. You just have to replace that. Alright, so that is successful. Click on these provisions now. You can save it now in DSFR. Okay, so you can be able to open it in AutoCAD and then carry out all the necessary editing and make it presentable for submissions. So this is a typical procedure and straightforward way of designing footings and as well as slab using RCDC and Staad vi8. I hope you enjoyed this lesson. Stay tuned for more advanced lesson and bye for now.